Good morning, students. Welcome to grade 11 business mathematics class. In our last class, we are learning about the properties of determinants. We have learned 7 properties of determinants and some problems we have completed in that section. I hope you all completed the home assignments as well as you got a thorough knowledge in the properties of determinants. So, in today's class, in exercise 1.1, 3 problems are there. So, the remaining 3 problems we will complete in today's class. So, in exercise 1.1, problem number 1 to 5 we have completed. Some problems I have gave home assignments for you. I hope you all completed. Let's enter into today's class. Let's start from exercise 1.1 problem number 6. Evaluate determinant 1a square minus bc, 1b square minus ca, 1c square minus ab. Listen students very carefully. First, solution. First, what I am going to do in this sense, using the property 6. So, in 6th property, I have taught you how you can split this into 2 matrices. Yes. So, according to that, we are going to split into 2 determinants. 1a square, 1b square, 1c square. Then here center it is minus, so minus 1a bc, then 1b ca, 1c ab. Understand? Using property number 6. Please students write down the property 6 here. Understand? What I did here, minus is there, so I split the determinants into 2. Okay, so first we are going to consider this determinant and we are going to evaluate, and next we are going to consider this determinant and we are going to evaluate, then afterwards we are going to substitute here. Understand? So I am going to take this as equation number 1. Consider this as 1. Okay, not an equation, so this one we are going to consider as 1. So first I am going to consider this determinant. What's this determinant? 1a square, 1b square, 1c square. I consider this determinant alone. Okay, so what I am going to do is, I need any 2 determinants. I need to take anything common outside, then only it will be very easy for myself. Okay, so for that, what I am going to do in this sense, R1 row I am going to change as R1 minus R2. Okay, same as R2 row I am going to change as R2 minus R3. Okay, for what I am going to change in this sense, if I am changing like this, then only I can take any terms common outside. Then only it will be easy for myself. So, I am going to change R1 as R1 minus R2 and R2 as R2 minus R3. Okay. So, R1 means what I am going to do? R1 minus R2. Okay. So, what will happen? 1 minus 1 means 0. Next, A minus B. That is A minus B. The next one, a square minus b square. Understand? R1 minus R2 means first row minus second row. Okay, so same as R2. R2 what I am going to do? R2 minus R3. So 1 minus 1 is 0. Then b minus c. Okay, b minus c. The next one is b square minus c square. Last row as it is. Have you got it? Okay. Next, what I am going to do in this is, I am going to change this, that is in the form of a square minus b square. Okay, so you know, so that is equal to 0. 0, A minus B. Already in lower classes you have learned what's the formula for A square minus B square? A plus B into A minus B. Here 0, B minus C. Next also we are going to change. So B plus C into B minus C. Last row as it is. Okay. That is equal to, now you can take common outside. Okay. So already I taught you, if any two row having the same elements, you can take anything common. Okay. Now I am going to taking A minus B, B minus C common from R1 and R2. Students, I already taught you the properties. If you are thorough in properties, then only this conditions and all you will get some idea. So learn the properties thoroughly. So I said this is right. If I need to take anything common, don't think that if all the three rows also need that common elements. Okay. So if it is common in any two rows also, you will take. Okay. So now A minus B and B minus C I am going to take common. Okay. So from R1 and R2. So here A minus B and B minus C I have to outside. So 0. This A minus B will become 1. Okay. Then next one A minus B I took outside. So A plus B is the balance. Then 0. This one I have to go outside. So B plus C is the balance. 1C C square. Okay. Then next I am going to evaluate. That is A minus B into B minus C. Now we can expand along this. You know how to find the determinant. Is it right? So open the bracket. First 0 into expand this and this one. Is it right? So 1C B plus C C square minus 1 into this and this will get cancelled. So 0 1 B plus C C square. Last one is plus A plus B into this and this will go. So 1 0 1 1C. That is equal to A minus B into B minus C into 0 into anything. Is it right? Anyhow 0. Okay. Minus C into B plus C. Anyhow it will become 0. Minus 1 into 0 minus of B plus C. Then plus A plus B into 1 into 0 is 0 minus 1. Okay. That is equal to A minus B into B minus C into this one 0 into anything 0. Then minus 1 into minus of B plus C. Okay. Plus A plus B into minus 1. That is equal to A minus B into B minus C into minus. Is it right? So plus. Then minus into minus. Is it right? Again plus C. Then minus A minus B. So what will happen? This 2 will get cancelled. So what's the balance? A minus B into B minus C into C minus C. Understand? Now one part over. Okay. Next, now we have considered this determinant and we have found out the value. Next determinant is there. So we are going to consider this determinant. Okay. So what's the next determinant? And we are going to consider the next determinant, that is 1A BC, 1B CA, then 1C AB. Okay. We are going to evaluate this one. Okay. So first, same as that one, we are going to do the elementary transformation. So that is equal to, what's the elementary transformation there you did? That one we are going to do R1 minus R2. Same as R2 implies R2 minus R3. Change it. What will happen? 0 A minus B. This and this one means how much you get? BC minus CA. Then next one 0 B minus C, then CA minus AB. Last row as it is 1C AB. Okay. Then next what will you do? We need to take anything common outside. Is it right? Before that we can take another one common. 0 A minus B. For this 2 what's common? C is common, is it right? So we can take minus C outside. So what will happen here? A minus B, we will get correct. If I am taking minus C outside, this will come first, is it right? A minus B. The next term is 0, B minus C. Same as that, here I am going to take minus C outside. So what will happen? B minus C. So 1C, AB. Okay. So same as that, again I am going to taking A minus B, B minus C, common from R1 and R2. Okay. So that is equal to 0. Common, is it right? What's the common? A minus B into B minus C is common. So what will happen? 0. Next term is 1. Next term is minus C. Then 0, 1. Next term is minus A. 1C, AB. Okay. Next we are going to expand along C. Okay. So expand along C1. Along C1. So what will happen? That's equal to A minus B into B minus C into, so open the bracket and we are going to find the determinant value. So this will get cancelled, is it right? So 0 into 1C minus A, AB. Then minus 1 into 0. This and this will get cancelled. So 0, 1 minus A, AB. The next one is minus C, is it right? Plus C you will get, here already it is minus C is there. So minus C. So minus C, this and this will get cancelled. So 0, 1, 1C. Correct? So that is equal to A minus B into B minus C into 0 into anything 0. So minus 1 into 0 into AB is 0. Minus of minus is plus A you will get. Then minus C into again 0 minus 1. Okay. That's equal to A minus B into B minus C into minus A, minus into minus plus. Okay, that is equal to A minus B into B minus C into C minus C. Okay, now we have got the two answers. So one answer is here, is it right? The next answer here it's there. Okay, so we are going to substitute the two values in equation number, in here. Okay, 1. So we are going to substitute. So 1 implies, what's the first value? A minus B into B minus C into C minus A. Center, what's the symbol? Minus. Okay, so minus, here what's the answer? A minus B into B minus C into C minus A. Okay students, now subtract it. A minus B minus A minus B, 0. So B minus E minus E B minus A, 0. C minus A is equal to 0. So what's the answer? Is equal to 0. Understand? Here only easy way is there. So you will get one idea. Ma'am, why we are using all the properties and all. Oh, sometimes if they are asking in 5-mark question, if we are not using the property, simply we can evaluate. Just you can try it in your home. Okay, just we are expanding along C1, that is 1 into this one you will cross multiply, then A into this one you will cross multiply. Just if you evaluate means also you will get the correct answer. 0 you will get. Okay, but sometimes if they are asking in 5-mark question, if you are not using their properties here, there is a chance to reduce the mark. Because of that, each and every line I used by using the property. Okay, that's the reason. Okay, you will get a doubt. Because of that, I explained this now. So it's very easy. If you are thorough in property, it will be easy for you. So for first consideration, how you are proceeding. So same thing we need to do for second also. Okay, so after that, if you subtract both answers, you will get a 0. Understand? Very, very important question. There's a chance to get asked for 5-mark question. So learn it thoroughly. Understand? 2 or 3 times again and again, write and see, then only it will be get thorough knowledge for you. Okay? Understand? Let's move to the next question. Another problem. Prove that determinant of 1 by A, B, C, B plus C, 1 by B, C A, C by C, AB, A plus B is equal to 0. Very simple question. So this problem also just we can expand along C1 and we can complete 0 you will get. There is a easy way if you are using property. Okay, solution. So first I am going to take this one. What's that? 1 by A, B, C, B plus C. Then 1 by B, C, A, C plus C. Then 1 by C, A, B, A plus B. Okay. What we are going to do is, I am going to multiply R1 by A, then R2 by B, R3 by C. Okay. We are going to do this. Okay. Multiplying R1 by A, R2 by B and R3 by C respectively. And we are going to divide the determinant by ABC. And dividing the determinant by ABC. You have learned in the property. So if we need to multiply any number by R1, we can do. Okay. So same as that, if we need to divide by any values, you can divide. So everything you have learned in property. So what we are going to do? We are going to multiply R1 by A, R2 by B and R3 by C. And we are going to divide the determinant by ABC. So first we are going to divide. Okay. Divide. So 1 by ABC. Next we are going to use the property. Sorry, we are going to multiply. What I said, first row we need to multiply by A. So 1 by A into A. Then next one BC is there, is it right? So BC into A, is it right? A into BC. Then next what's there? B plus C, is it right? So A into B plus C, correct? Then second row what you need to do? You need to multiply by B, is it right? So 1 by B into B. So 1 by B into B. Then next value what's there? CA is there. So B into CA. Then B into C plus C. Then last C is there. So 1 by C into C. C into AB. Then C into A plus B. Now multiply, that's equal to 1 by ABC into this and this will get cancelled, this and this will get cancelled, this and this. So 1, 1, 1 you will get. So ABC, ABC, ABC. So same as that, here you multiply AB plus AC, then CB plus AB, then CA plus C. Okay? Understand? Understand? Okay. Next we are going to do is taking the ABC common from C2. Okay. We are going to taking ABC common from C2. Now listen here students, where is C2 column? C2 here. This is C2, is it right? In C2 column what is common? ABC is common. So we can take common outside. So into ABC. So what will happen? 1, 1, 1, 1, 1, 1, AB plus AC, CB plus AB, CA plus CB. Okay. Now this and this will get cancelled. Okay. Now I have explained you in one property. What I explained? If any two rows or columns are identical, here C1 and C2 are proportional or identical. Okay, C1 and C2 both are same as C1 all the numbers are 1, C2 all the numbers are 1. So both are same, correct? So how we will conclude the answer? C1 and C2 are proportional or identical. So what will we say? The determinant value is equal to 0. Hence not. Understand? If any two columns or any two rows are identical, we will say the determinant value is equal to 0. You learned in property. So if you are using that property, we will get 0. Understand? Listen here. Last problem in this exercise. Solution. What's the LHS? Minus A, AB, AC. AB minus B square, BC. AC, BC minus C square. Okay. Now we are going to taking A comma B comma C common from R1, R2, R3 respectively. Understand? We are going to take A common, as A is common, next row B is common, next row C is common. We are going to take its outside. So what will happen? A, B, C. Now I took outside. So what's the balance? Minus A, B, C. A I have to common from R1. B is common in second row. So what will happen? A minus B, C. Third row C is common. So A, B minus C. Am I right? Then next what we are going to do is again taking A comma B comma C common from C1, C2 and C3 respectively. Understand? First I have took R1, R2, R3, A, B, C took outside. Next what I did? I am going to do take column wise A, B, C. So first column A is common, second column B is common, third column C is common. So I am going to take from column wise. Okay. So already here A, B, C is there, is it right? So if I am multiplying again, what will happen? A, B, C will get. So what's the balance? Minus 1, 1, 1. Then 1, minus 1, 1. Then 1, 1, minus 1. Correct? Now I got it. Okay. So next what I am going to do is, outside if you are multiplying means ABC into ABC, A square, B square, C square you will get. Again I am writing the determinant. Minus 1, 1, 1, 1 minus 1, 1, 1, 1 minus 1. Okay. So now I am going to apply R1 implies R1 plus R2. That is equal to A square, B square, C square. What I am going to do? R1 plus R2. So minus 1 plus 1, 0. 1 minus 1, 0. 1 plus 1, 2. Then 1 minus 1, 1. 1, 1 minus 1. Understand? I am going to change R1 as R1 plus R2. That is equal to A square, B square, C square. I am going to expand along C1. So 0 into anything you will get a 0. If you need, you can write 0 into this and this it will go. So minus 1, 1, 1 minus 1 you will get, and minus 0, this and this will go. So 1, 1, 1 minus 1 you will get. Then last row plus 2 into this and this will go. So 1 minus 1, 1, 1. Okay. That is equal to A square, B square, C square into, so this will get 0. This also value will be 0. So 2 into 1 into 1 is 1. Minus of minus plus 1. Is it right? So 2 into 2, how much will get? A square, B square, C square into 4. So the answer is 4 into A square, B square, C square. This problem also very important. Students, again I am saying, you will get checked out. Why we are doing all this A, B, C taking outside, then commonly taking from the column. Why we are applying this and that. You will get some confusion. Is it right? So simply if we are expanding along this C1, just you try. Okay, just you try. You will get the same answer. Okay. If I am writing like this, minus A into this and this I will remove, and if you are cross multiply this one, then minus AB into this and this you will remove, and you will get cross multiply. AC into this and this you will remove, and this will cross multiply. And if you are finding the determinant value, you will get the same answer. Okay. But sometimes there is a chance to reduce them. Because of that, we are following your book method by using the properties. The reason is properties of the determinants. Is it right? So they will think why we are not using the property. So because of that, each and everything we are applying the property and we are doing. Understand? Have you got it? I hope you all understand. So these 3 problems also very important, students. Take it to your notes. So our first section, that is exercise 1.1 over. I hope you all got good idea in finding the minor, cofactor and how to evaluate. That is properties of determinants. Understand? Let's move to the next section. For next section, just I am giving the introduction. Just to listen. Understand? Students, next section is inverse of the matrix. Our next section is inverse of the matrix. Okay, inverse of a matrix. There are 2 definitions we are going to learn. First one is singular matrix. Next one is non-singular matrix. Okay. So a square matrix, already I have explained what you mean by square matrix. A square matrix A is said to be singular. When will you say it is singular? Determinant A. Is it right? You know to find the determinant value. So when will you say it's a singular matrix? If the determinant A value is 0, then you will say it is a singular matrix. If the determinant value is not equal to 0, then you will say it is non-singular matrix. That's all. Understand? Have you got it? You copy from your book. These two definitions you need to write it in your note, copy from your book. Okay. Now you got it. So it's a square matrix. That's very, very important. A square matrix, when you are finding 2 by 2 matrix, just if you are taking square matrix means 1, 2, 2, 3. Okay. If I am finding the determinant value, what will happen? 1 into 3 is 3. Is it right? 3 minus 4. You will get minus 1 is. So minus 1, whether it is equal to 0, not equal to 0. So it's a non-singular matrix. If I am getting the answer as 0, you will say it is singular matrix. Understand? That's all. I am thinking to do one problem. Okay. So example 1.10, show that 1, 2, 2, 4 is a singular matrix. Singular matrix means what's the condition? A square matrix, if you are finding the determinant value 0 means you will say it is singular. If it is not equal to 0, you will say it is non-singular. So here you need to get the answer as 0. Correct? Solution. Let A is equal to given matrix, you take it as A. 2, 4. Now we are going to find the determinant A. Already I taught you the determinant symbol. Determinant A is equal to 1, 2, 2, 4. How will you find the determinant? Just you will cross multiply. So 1 into 4, 4 minus 4. What's the answer? 0. Determinant A value 0. Therefore, A is a singular or non-singular? A is a singular matrix. Understand? Singular matrix. Another one small example. Next problem. 1.11. Show that 8243 is non-singular. So non-singular means what will you prove? Determine A value not equal to 0. So same as that. Let A is equal to 8243. Determinant A equal to determinant of 8243. Just you will cross multiply. 8 3s are 24. 4 2s are 8. 24 minus 8 means 6. Whether it is equal to 0, not equal to 0. So determinant A not equal to 0. Therefore, what is the answer? A is a non-singular matrix. A is a non-singular matrix. Understand? I hope you got some idea. So this all the things in singular and non-singular. So next section is adjoint of a matrix. Our next section is adjoint of a matrix. It's new for you. Just I am giving the definition alone today. Okay. So adjoint of a matrix. The adjoint of a square matrix A is defined as the transpose of a cofactor matrix. So already I taught you what is cofactor matrix. Already I taught you transposes. So what is adjoint? Transpose of a cofactor matrix. So for finding the adjoint, what you need to do first? You need to find the cofactor matrix. Okay. Afterwards, what will you do? If you find the transpose of that particular cofactor matrix, you will get the adjoint. So simplest thing is adjoint A is equal to Aij. Aij means cofactor matrix. The simple thing is adjoint means transpose of cofactor matrix. Understand? Transpose of cofactor matrix is called the adjoint of a matrix. Transpose of cofactor matrix is called the adjoint matrix. So here one small problem is there. If I am explaining this problem, exercise 1.2 first problem you can do as homework. Okay. So I can complete that also. So example 1.12. Put the side heading adjoint of a matrix. Take the definition from your book. So find adj for A is equal to 2, 3, 1, 4. You know, is it right? A is equal to 2, 3, 1, 4. Solution. So what is adjoint A? Adjoint A is equal to Aij, the whole transpose, correct? So I taught you in one question, row change to column, column change to row, is it right? Row change to column, column change to row, yes? So that is transpose, you know. But students, listen here very carefully. The given matrix is a 2 by 2 matrix means we can use one simple idea. Okay. No need to find minor, no need to find cofactor, no need to find afterwards the transpose of cofactor matrix and all these are the things. No need. Within one line you can write the answer. Okay. But correctly you need to understand that one. It is possible only for 2 by 2 matrix. It is not possible for 3 by 3. Okay, understand students? So it is possible for only 2 by 2 matrix. So now what we are going to do is these two numbers I am going to interchange. So 4 will come here, 2 will come here. Okay, that one I did. Next one, this number 3 and 1 as it is, but you need to change the sign. This is the answer. This much only. Okay, got it? What we need to do for finding adjoint for 2 by 2 matrix, just need to interchange these two numbers and just you change the sign of these two numbers. That's all. This is a adjoint. No need to find minor. If sometimes they will ask, find the minor, find the cofactor. For that separately you will do. In last exercise we have completed. So same as that you need to do. Otherwise, simplest way, it is applicable for only 2 by 2 matrix. If it is 3 by 3, it is not possible. Separately, you need to find all the minor and cofactor afterwards to transpose of cofactor matrix. But in 2 by 2, just you can change these two numbers, these two entries. For this two, just you change the sign. That is, here it is plus means minus. If it is minus, it will change as plus. That's the answer. Understand? So, only one homework I am giving. Simple problem, that is exercise 1.2 problem number 1. Same as this question. Within one line you can write the answer. So today your main work is I taught 3 important problems. That is last exercise 6, 7, 8. Now itself learn, go through that 3 questions. Now itself one time you write and see the 3 particular questions. Understand students? I hope you got some idea. So from the next class we will start how to find the adjoint of 3 by 3 matrix. I will taught you. Okay. So just wait for the next class. I will meet you in the next class. Thank you students.